Well, welcome back. Having added fractions and subtracted fractions, we take the look now at multiplying fractions. Adding and subtracting fractions required a least common denominator. Multiplying fractions does not require a least common denominator. Let's try to figure out why. So y is 2/3 times 3/4 equal to 6 over 12. Why is that? If we imagine some whole unit, 2/3 times 3/4, that's 2/3 of 3/4. So 3/4, well, what's that? 3/4, that's 3 of these 4 parts of the whole. This is 1/4, this is 2/4, this is 3/4. We want 2/3 of that 3/4. Well, we take the 3/4 and we divide it into thirds. Well, let's divide into thirds. We want 2/3 of those 3/4. This is 1/3. This is another third. So what have we really chosen? We've really chosen this area here. We chose 2/3 of the 3/4. Well, how does that compare to the original whole? Well, if we slice by fourths this way and slice by thirds this way, that's 12 pieces. And we have chosen 1, 2, 3, 4, 5, 6 of those 12 pieces. So 2/3 times 3/4 is 6 over 12. Let's pause for a moment. Think about how you would model for students why that's true. Think, pause if necessary. Why is that true? Hopefully your explanation looks something like this. We want 3/5 of 1/6. Well, we figure out what 1/6 is. That's this red strip here. And then we take 3/5 of that 1/6. So we slice into 5 pieces this way, choosing 3 of those 5. So there are 30 small pieces in this whole unit. We have chosen 1, 2, 3 of them. 3 over 30. Now, I know what you're saying. What about cross-canceling? What about the thing that our teachers told us where they said, oh, well, 2 goes into 2 and 2 goes into 4, and then 3 goes into 3, 3 goes into 3, so it's really 1 times 1, and it's really 1 times 2. Is that still right? Well, yes, 6/12 is 1/2. Yes. Why? So focus here for a moment. This says that we're going to divide pieces into thirds, and this says we're going to pick 3 times as many of them as we would have normally. So every time we see that, we know that the one undoes the other. Similarly, we're going to take pieces and divide them up into 4 times as many pieces as they were before. But don't worry, we're going to take twice as many of them. Well, that's the same as dividing the pieces into 2 smaller pieces and choosing one of them. So canceling works, like it's fine, but there's a reason why we do it. You'll note that the other example was 3/5 times 1/6. We can do the same process here. Uh, if we divide the pieces into 6 times as many pieces as there were, but we take 3 times as many, that's the same as just dividing the pieces in half and picking one of them. So 1 times 1 is 1, 5 times 2 is 10. 1/10 happens to be the same as the 3 over 30 that we have from before. Okay? Okay, so what's the deal with mixed numbers? We, we can't multiply mixed numbers in the same way, because what do you mean multiply across the top, multiply across the bottom? That's crazy. So instead, we decide to make the 1 and 1/3 into an improper fraction over 3, and we make the 1 and 1/2 an improper fraction over 2. So 1 and 1/3. Well, 1, that's 3/3, and you have another 1/3, so 3/3 and 1/3, that's 4/3. And similarly, 1, that's 2/2, but here's another 1/2. So 2/2 and 1/2, that's 3/2. Now this is something we can get behind. We can figure out that 4 times 3 is 12, 3 times 2 is 6, and 12 divided by 6 is 2. You should think for a moment about how this works. Well, I hope you did something like this. 2 and 1/4, well, 2 is 8/4, and there's a 1/4 hanging around. And then 3 is 15/5, and then you have an extra 2/5 lying around, and then we multiply straight across. This happens to be 7 and 13/20 as a mixed number. So multiplying fractions boils down to the area model where we take our pieces and divide them into pieces. And that's all this process does. That's how we justify the multiply across the top, multiply across the bottom thing. We'll justify division in an in-class activity. Looking forward to seeing how we do with that.